I'm not sure how old are you, but I still remember this game, Doom from 1993. This game was huge when um, during the early years of 90s. It is a first-person shooter game developed and published by ID Software. It was released around December, I still remember, in 1993 for DOS, which is a disk operating system. And the player assumes the role of a space marine and later, which are unofficially referred to as Doomsky, and it just fights through hordes of undead humans and invading demons. Quite interesting. Now, instead of you or humans, the models, the diffusion models to be specific, can play this game and way better than humans. Can you believe that? So Google has released this GameNGen, or as they say, GameNGen diffusion models that predict next frame of this Doom shooter game playable at 20 frames per second. And that is not as small thing as one might imagine. I think this is huge. And I think we are just at the cusp of seeing how the game playing gets changed all over the globe. Models will be playing them, you will be playing with the models, all of these complex games easily. So I still know that if you want to play a two-person game, it's very hard to find the second person, because you're, even if you have kids, they might not want to play the games you want to play. But now you will have models which can play with you or against you. How good is that? So let me show you a couple of videos. So this is on their project page. I'm going to play it, and I will also drop the link to it in video's description. So this is this GameNGen model playing this game, not the human. This is simply amazing. You see how accurate this model is with all the maneuvers and all that stuff. Good stuff. Okay, let's try out another one. Check out this one. So it is strategizing, it is looking, it is absorbing the whole atmosphere. You see, it went in. Let's try another one. I can't wait to see these models play Minecraft. That will be simply amazing. There you go. Look at this one. Check out this one, how it is moving, recognizing the characters. And just today I did a video on another vision language model, just 2 billion, and the quality was great. So I have no doubt in my mind that you'll be playing the games with or against models on your mobile phones in the matter of months, if not weeks. So amazing, sort of thing. I could go on and on this one, but this looks real crazy here. Okay, and you can watch other videos on their model card. Let me um, show you the architecture of this model. So this is the architecture where they are describing how this model works. Let me try to explain. So look, computer games are manually crafted software systems centered around the game loop. And in this game loop, at a very high level, what happens is that the game gather user inputs, it updates the game state, render it to the screen pixel. That's it. This game loop running at high frame rates creates the illusion of an interactive virtual world for the player. Such game loops are classically run on a standard computers, and while there have been many amazing attempts at running games on bespoke hardware, for example, the iconic game Doom has been run on kitchen appliances such as toaster and microwave, a treadmill, a camera, an iPod, and within the game of Minecraft, to name just a few examples. In all of these cases, the hardware is still emulating the manually written game software as is. Also, while vastly different game engines exist, the game state updates and rendering logic in all are composed of a set of manual rules programmed or configured by hand. But we have seen that in the one last year, these models made significant progress in producing images and video conditioned on multimodal input such as text or images. And at the forefront of this revolution, diffusion models have become the de facto standard in media, or in images and video. Like we have Delhi, we have Stable Diffusion, we have Sora, and lot of others. And at a glance, simulating the interactive world of video games may seem similar to video generation, but interactive world simulation is more than just very fast video generation. The requirement to condition on a stream of input actions that is only available throughout the generation breaks some assumption of existing diffusion model architectures. It requires generating frames autoregressively, which tend to be unstable and leads to sampling divergence. So this is where they have shown that a complex video game, the iconic game Doom, can be run on a neural network, which is an augmented version of the open stable diffusion in real time while achieving a visual quality comparable to that of original game. While not an exact simulation, the neural model is able to perform complex game state updates such as tallying health and ammo, attacking enemies, damaging objects, opening doors, and persist the game state over long trajectories. So, GameNGen answers one of the important questions in the road towards a new paradigm for game engines, that it is going to be playing the games as best as humans or even better. So if you look at this diagram, which is the GameNGen overview, where for the prediction details are omitted, but it still tells you that it is a generative diffusion model that learns to simulate the game under the various settings. In order to collect training data for this model with the teacher forcing objective, they have trained a separate model to interact with the environment, and then the two models, both agent and generative, are trained in sequence. The entirety of the agent sections and observations during the training is maintained and becomes a training data set for the generative model in a second stage. End goal End goal is to have human players interact with their civilization, and I think they have already succeeded in that. So let me know, what do you think? I'm very impressed by it. I will drop the link to this in video description. Play around with it and let me know how you go. So just one quick thing, if you just scroll down, and this is where I was playing it. So I was showing it to you, and you can just simply scroll to the right to see all the variations which I was showing you. And I'm just going to just make it slightly smaller. This is what I was talking about. So this is where you can check it out. So that's it, guys. Let me know, what do you think about it. If you are a Doom player, I'm very keen to hear your opinions specifically. If you like the content, please consider subscribing to the channel. If you're already subscribed, please do me a favor and share it among your network, as it helps a lot. Thank you for watching. Much appreciated.